wants to do his last year.
Multicast is used more than ever, right? I think so.
Oh, absolutely, yeah, it's kind of funny, but it's where's the noise?
Yeah.
And you know that every new architect, well, can we get rid of it?
Well, once it's well deployed, then it would only be a small proportion of the traffic.
I was talking to the CTO that said he wanted to get rid of it because it was only like 10% of his traffic. And when you said,
Guess how much
well,
it would
if
be?
you remove it, it's gonna be 200% of your traffic, so.
I think we're gonna need to come up with better statistics. I mean, really, you can make an argument for taking the number of users watching a stream and multiplying that by the full path bandwidth and
Yeah.
using that as your
Yeah.
metric. Like, that's how much data you're delivering.
We should write that draft.
Well, actually, I actually wrote a grant for the University of China to do a model on this big rack I had, to just basically do pin infrastructure, unicast infrastructure, I wanted to do an AMT, like compare them all and just full price. And we could have dropped in complete network designs. I haven't looked. It was a big viral demo we do on the mini pods we had. Then we dropped the mini pod and I just want to support it. This happens over and over again. Everywhere I play, they like take the toys away.
Would you like to start shaming people into subscribing?
You can. Gotta give you some minutes first.
I'm busy. I can take it.
Sure. Are you sure up for it?
Not
This is
during
a
my,
cold ask on my part, I know.
not during my time, but.
Okay.
I'll
You gonna cover it?
I'll take your notes.
Okay.
Yeah, you're gonna do me.
You guys are great, I'll get yours.
All right, you actually.
I've had too much beer as it is.
He made eye contact with the wrong tone at the very
Looking
the
dumb.
worst moment.
Actually, Jake just told me that worked outside before the meeting.
They talked-
I walked up and hit him.
You,
That's cold, man. I'm so sorry. I owe you beers for years.
That's the worst show ever.
Yeah, you had to show that it worked too. You couldn't just watch it.
It's all good. It's all good. This is the way it works. We need minutes.
We can't, this plane cannot take off without someone doing the safety lecture and the,
No, we're at it. We got minutes.
yeah, so we're good, right?
Yeah.
Do we want to wait another minute? We're kind of in the corner here and maybe people are on their way converging, so
When we go outside with a megaphone, do holler down the street.
just grab them violently and pull them in.
You know, it seems like multicast should have like a, 1920s holler or something. Just kind of vaudeville stage with this little horn.
Come on.
Yes.
That's right. Every man a presenter.
Everyone's a winner. Come on in. Hurry, hurry, hurry.
Yeah.
Urban transport.
There might be a few more people coming. You know, so we don't have
It's Thursday now.
to-
It's Thursday.
We have more attendees than we had presented.
I'm actually looking for this. I was actually looking for your.
You should.
Oh,
No, it wasn't taps.
it's like this.
I can't. Oh, box. Yeah.
Hopefully it's in the right room. Like the Simpsons, it's like mass is going on, and it's like, oh, I'm so glad someone showed
But
up.
I think I actually
asked during the Super Bowl thing.
Oh my God, the game is on.
Even though every time I say
Simpsons.
Okay. All right, I guess we can start.
Sure. Go ahead.
Oh, God, man, they're gonna turn.
All right, so we have a jobber scribe. Warren, you got that?
Excellent, thank you.
Okay, we're ready to get started. Welcome to Mboned. Get to know your neighbor. Introduce yourself to everyone. Hopefully you're all meant to be in Mboned. Here's the note well. You probably haven't seen this yet, but it actually can be read in iambic pentameter. Yes. Yeah, it's a fun fact. It was written in iambic pentameter. Please note it well. Here's our agenda. And I think a lot of the folks in here are going to be presenting. So would anyone like to bash this agenda? I don't think we have a whole lot of potential controversies on this agenda. Okay, so let's get started with the status of the active drafts. The first two drafts, the Dryad draft, Jake's Dryad draft, did just complete working group last call. It is in the hands of the Shepherd, and we would like to thank Tim Chown for volunteering to shepherd that one. The MCAS problems draft did complete working group last call with, there were some minor revisions. We'd like to kind of go through, Charlie's going to provide an update on all the changes that were made. Most of them were textual, some were, everything was minor, but there were a few additions. And let's decide if we think we need another working group last call for that one based on those last few changes that were made. And whenever that's ready, though, because it did seem to successfully complete, we had enough support for it to move on. Thank you to Jake for volunteering to be the shepherd of that one. Next, we have two drafts that are in active working group last call. So here is an opportunity. Here's your opportunity as a reminder to please provide feedback if you support or do not support working group, the advancement of these documents. Please speak up. We're running that last call for the next few weeks, but we wanted to run it through IETF so that we could remind everyone in the room that, hey, here now would be a good opportunity to, if you forgot to send, hit the send button on your email that you have feedback on these drafts. Now's the time to do it. The last active work draft is the Yang models. And Sandy wanted me to bring this one up because she is looking for feedback as well. Is this ready for working group last call? First, what is the Stig or Warren? What exactly is the process for the Yang doctors? Do we send it to them after working group last call? Do we send it to them for feedback prior? What are we supposed to do? What's the interaction?
Stig, so you can actually go in the data tracker and request a Young Doctor review.
Okay.
You can do that before last call if you
Okay.
want.
Doing it early, I think, is for good, so you can find any issues.
Yeah.
in case they're
Fix them now.
Yeah, the earlier the better.
Cool. While you're up, Stig, I'm guessing you have the highest percent likelihood of actually have read this. Have you read it? Do you have any thoughts?
I have read it, but I feel like, I don't know, I'm not that much involved with Yang myself, so it's kind of hard for me. And I'm afraid it's the same problem with most people in the working group, that we don't maybe know Yang that well.
Okay.
And also, though, ideally there should be operators. So they were saying, does this model include what we need? But
Gotcha.
yeah.
Okay, so we need more provider input on this one.
Yeah, Jake Holland. I asked Sandy about this because my opinion was basically, if it works, it looks okay to me. I read it also. And she said that, yes, they've been running it and it's in testing.
Mm-hmm.
So I don't know how to incorporate that feedback into the consensus process, but I feel like that is the, if it actually works for deployed systems, then we probably should rubber stamp it and get this out the door.
Stig again. Yeah, I agree. It's possible that it doesn't include everything that ideally should be there, but we can always, if we find stuff that is missing later, we can always revise it or extend the model. There's no harm in maybe
Okay.
starting with just the basics.
So now's a good time to request Yang doctor review, I guess. Okay. We will note that.
People don't call it rubber stamping, though, it's just
Okay.
Well, it's more than I, but it's also better.
I'll revise that.
Yes.
I don't.
Please go back and doctor the,
Nothing jumps out at me.
yes,
Yeah, make sure those are all in the minutes.
yes. Please doctor the notes so that it doesn't say the cynical things that we mean. Other docs, there's the ambi draft. And Jake, anything you want to say about this, or will this be covered a little bit in your hackathon update?
Yeah, Jake Holland. I have not implemented this yet, but that is the plan. It's going to be necessary. It will. I will touch on it briefly in my hackathon update. I'd be happy to take questions about it, and I think I'll have my slot has plenty of time then. So yeah, please. It is. I'll just say it is still highly relevant and will be coming up again.
Great. Okay. Moving right along. So we will start with okay. Human put together this slide deck. He is not here, unfortunately, but he wanted. Stig, would you like to speak to this, or shall I?
Good if you want to. I've been discussing it with him, and I also spoke to Ayana earlier today.
Take to the pink X.
Say the same thing. Look how aware he is. Isn't he aware?
All right. I haven't seen this slide, so. All right, so mtrace version 2 was published as an RFC recently, and we got a UDP port number from Ayana. But then it turns out that that port number is in a range used by traceroute on Linux and I think on some other Unix operating systems as well. So I'm not sure how much I need to explain, but basically traceroute uses like 100 ports or so. But they only got one port assigned from Ayana, which is in the port registry. The port numbers coming after that, the next several hundred ports were just marked as unassigned. And mtrace was the first application or service that got a port number in that range. And the problem we're seeing now is mtrace is actually working just fine. But if someone does a trace route, what trace route does is, I think it's like the first packet has like the lowest port number, the next one with a higher TTL has the next higher port number, and so on. And then you expect from routers on the path to get an ICMP message back because there's nothing listing on that port. And you can then mark the show the round trip time and stuff to that router. But if something like mtrace is listing on the port, then there's no ICMP message coming back, and it will just show up as a star and kind of like timeout and trace route. So the problem here is not really mtrace, but trace route is sort of broken.
Is there any spec for this trace route behavior?
No, I don't think so. There's just lots of implementations.
Yeah, Kyle Rose, is there, who maintains traceroute, or is it just kind of like dead code that's?
Right. No, I mean, it is being maintained. So I'm not sure, it's been around, of course, for decades, and there's probably several implementations, and some of them are maintained, some are not.
Yeah, I'm just wondering if it's if it's had this behavior for long enough, it's sort of like grandfathered in.
Yeah.
So, but then it would be up to us to basically I don't know, can we make sure IANA reserves this? I mean, okay, we
Right.
get a different port.
Yeah, so I spoke
Unless we get
to,
a bit different port, we're not going to say anything, because first we want to have mtrace work, but
Yeah.
then basically IANA needs to block this race.
yeah, so I can comment on
Before we
that.
go that far, so I have a
Name?
question. Lenny, Giuliano, Juniper. So here's what I don't get. I mean, Windows doesn't do this. Windows sends an ICMP echo reply and with a TTL. And the important part is it sets it with a TTL and it expects a TTL expired. The fact that Unix is sending it with a UDP port and a different port, what does it matter? It's waiting to hear back. Why isn't it behaving the same way, which is I can pick out any port I want. It doesn't need to go anywhere. It's the ICMP TTL exceeded message that comes back. Why does this break?
So the problem is, let's see. Yeah.
So this is the question I had for Human, and
Yeah.
he wasn't sure either. He said he was aware of an implementation that this was breaking, but to me, it's not clear. Let them squat on these ports. Do these ports matter?
Yeah. So at least I can say some implementations like Windows, I believe, only use a single port number. But I know, for instance, on Linux, for some reason, they use a different port for the different distances.
So, Warren Kamari, as far as I understand, Unix uses multiple port numbers because otherwise you have to send one traceroute packet, wait for it to come back, send the next one, wait for it to come back. If you spread it across multiple port numbers, you can fire a bunch of them and get your responses faster, is what I'd understood. Whatever the case, traceroute has been around for so long and is so widely implemented according to the Unix way that I don't really think we can say, all implementations should go off and fix themselves.
Yeah.
There's equipment that's been deployed for so long that
Yeah.
I think we kind of, in fact, I think that Juniper, for example, does their trace routes using multiple port numbers as an example. Simon, I think the right thing to do here is be like, oops, we're going to have to move, and then ask IANA nicely to
Yeah.
please block off all of these.
Right. So I spoke to IANA in the break here, and comment before that, or
I have to ask somebody who knows better, but I thought there was also something related when you go through a net and a firewall or so. But so I think Kumari's. Was good.
No, I'm sure there are some reasons for this. But yeah, I spoke to IANA in a break, and they were saying, it should be possible for us to get a different port number. We may need our AD to sort of approve of it or something, I'm not sure. But I guess, though, if you were to change the port number, it means that we need to update the existing RFC, maybe even obsolete it to make sure that people don't implement the old one with the wrong port number. I don't know. But we need a new RFC at least with a new port number. And then ask IANA to update the registry.
Has an errata been filed?
I don't know.
Yeah, so the first thing is file an errata.
But it's not really an errata.
Because it's not errata yet.
No, it's an errata insofar that it doesn't work, right? I mean, at least that's.
No, mtrace works. It's traceroute that breaks now.
Okay, all I'm saying is we have process to create visibility. I would be more worried about making sure there's visibility than whether or not it 100% matches the intended process.
Yeah, I mean, wow, static. Something similar kind of happened Warren Kamari still. Something similar happened with HomeNet, where there was some advice which turned out to not necessarily be great. I'm not saying that that's what happened here, but I think the right thing to do is to file an errata. Errata can't be used to actually update an RFC, and so it would have to be rejected or marked for document update, but at least we can point at it and there's some warning. And then at the same time, there should be a new RFC, like a new draft, which can move to RFC really quickly, being like identical to the last one with the string change.
So we would need a new RFC. We couldn't just use errata and just say, and change the port through that.
No, I wish you could, but I think it's going to be,
Yeah.
but it should just go through the process really easily, especially if the only thing that's changed is one thing there, and it should be already fast.
Yeah.
You know, you could also ask the RFC editor to do expedited processing because it should be a single number change. And maybe like a paragraph explaining
Why?
why.
Yeah.
It's unfortunate, but
Jake Holland, do we know how to avoid colliding with the next port we choose?
well-
Let's not actually look at the notes. Get the very
No comment, but
I guess we can Google it, and, do a man on trace route and see what.
but yeah, the other thing Ayana said is we can report that that they are kind of like using some unallocated ports that traceroute is, and they can kind of block it internally so they don't accidentally give those port numbers to others. But ideally, they would prefer if we can find someone from the traceroute community, whatever, that can sort of officially request
Answer
the full
for their
range for traceroutes.
discretions. You can know where to send IANA to send the IANA police. Jackbooted thugs.
Right, yeah. But yeah, we can just find, like the maintainer or who last made a change to Linux traceroute or whatever. And
and ports are within jurisdiction, I assume. Okay.
I feel safer.
It's good to know we've got somebody on the beat.
I'm sorry.
All right, so I guess the plan is we will file errata, and then we will reach out to IANA to tell them what's going on, and then we will resubmit a new,
yeah, I guess you need
what we're doing.
you need someone to volunteer to write a new draft, I guess. The office of the old draft, whatever.
Well, we've got Hitoshi here, and you saw that document for a long time. So I assume you might want to be involved in this one as well. So this should be the easiest revision you've ever made to that draft after, I believe it was 18 versions, or were we in the low 20s? It was, yeah. 26. All right, well, and here I said 26th time is a charm. Apparently I was wrong. Okay. Okay, next up is Charlie. Charlie, are you online?
I'm here. Can you hear me?
Barely.
Well, let's see. How's that? Is that any better?
Each time you speak, it's a little bit better.
All right. Well, I'm not sure what more I can do. Let's see that's about
Yep,
it.
you're good.
Okay.
You're good.
All right. Well, I'm Charles Perkins, and I'm here to describe the changes since the last IETF for the multicast considerations over IEEE 802 wireless media. So I guess next slide, please. Or is that something I can do to change the slides?
No.
Okay.
Apparently there's
All right. Well, so after
actually
the
gets there.
after the last IETF and during the discussion in the IETF, there were quite many comments. Some of them were generated at the hackathon, and after that, I submitted revision number 5 on April 15th and requested working group last call. Next slide, please. So here's a list of some of the changes. There was a new section. Essentially, Jake Holland just gave me the text for conversion of multicast to unicast and included AMT as an existing solution, and described some future applications that would emphasize the need for attention to the technical matters that are described in this document. There were several places all along in the text that were generic to sort of, that needed to be more generic instead of referring to specifically IETF conference solutions. And so those have been sort of caught more and more over time. And I hope it's all done, but it could still be interpreted perhaps in a too specific way some places. But added UPnP, Universal Plug and Play, as a representative multicast protocol, and cited the bridging code for people who wanted to convert multicast to unicast. And then there's a lot of bibliographic citations, and actually there's more updates are needed, which I'll get to that a little later. And then more editorial improvements and grammatical corrections. The next slide, please. So that was submitted on April 15th, and then there was some more discussion on the mailing list. There's been some really good discussion. Jeffrey Zhang made a comment about, I think it was a super user webpage that had a lot of discussion about the problems in this draft, and mentioned some more things that hadn't been considered, specifically about how wireless failures can really complicate problems with multicast group membership. So the way of handling that comment was to update the security considerations, and really ended up just sort of summarizing some of the text that was on the web page. The other big change that was done was really, there was a lot of comments from Bill Atwood, who made an extremely detailed and appreciated review of the document. And he also suggested including Dryad as a relay discovery possibility. Next slide, please. So then that all those things resulted in submitting revision number 6. I think that was done in the early part of July. So there was, as I mentioned, new text in the security considerations, and also including Dryad as a discovery mechanism. And I actually did an English refresher course, learning about when to use which versus that, and amount versus number, and a few other things. And then more bibliographic updates and editorial improvements. Next slide, please. Well, since then, there's been some more email from Bill Atwood pointing out a few other things that need to be taken care of, and plus email from Jake Holland. And interestingly enough, Jake is arguing that Dryad should not be listed as a discovery mechanism because it's really useful from the remote side, and also a few other minor corrections on the draft. So that's pretty much it, what I have for now. The next document, I thought I would try to get it out this week, but that didn't really happen. And anyway, it's probably better to wait to see if there's any additional comments during this face-to-face meeting, or let's say almost face-to-face. So next slide, please. So that's what I just said. I will produce a new draft quite soon. And if there's any additional reviews, oh, and by the way, I guess a special thanks to Warren Kumari for motivating people to submit some reviews for the draft. That was very helpful. So that's it for my presentation, and I'll be happy to answer questions, but I just want to mention that sometimes, yeah, I think you have to be close to the mic, because sometimes the echoes in the room make it hard for me to hear what you're saying otherwise.
Great, thank you, Charlie. So I think given the changes you've described, I think after you get that next rev out, I think we should have a brief, another working group last call, because these are, some substantive additions. So we'll run another quick last call, just so that folks have an opportunity to review what the changes have been made, and make sure there's no objections to those changes.
Okay, well, that's fine with me. I also would just mention that I try to be somewhat inclusive in the changes section in the appendix. So you can take a look at that and get a hint about what's been changed.
Warren Kamari, absolutely no hats. If you do another, or when you do another working group last call, is it going to be one where you expect replies, or will silence be taken as consent, or how do you want to run it? Just last time it was really hard to get any comments.
I would be fine with doing silence equals consent. Can the AD thumbs up that one? Assuming the AD does not object to that.
Probably not, because this AD isn't responsible for this document.
Okay.
I mean, if it's already gone through one working group last call, I think
Yeah.
that chairs have the flexibility to say, this is the changes. Does anybody object?
Yeah,
In the past, but
that's how we'll frame it, yeah. Please speak up if you have any objections to these changes. So Charlie, when you do submit it, send to the working group just kind of maybe a diff between that shows specifically, so that folks don't have to dig hard, but that they can specifically see the new text that was added since the original working group last call. And that way it's easy for people to review, and if they have an objection, they can speak up.
Okay, when was the original working group last call made? Like a month ago?
It was a while ago. I would say something like the beginning of May.
Okay, so then I'm going to, in order to satisfy your request, I'll include all the changes from draft 5 up to draft 7.
Sounds good.
Okay, well, that's it for me. I'm sorry I can't be there in person, and thank you very much to the Meet Echo crew. It's really very good.
Thanks, Charlie.
Yeah. Thank you, Charlie. Okay, Kyle, come on down.
Take to the edge.
The pink X. Hi, I'm Kyle Rose. I work at Akamai Technologies, and this is work that I'm doing with Jake that is intended for multicast. So I'll set up the problem.
This actually works
Oh, excellent.
for you.
All right, so I'll set up the problem here. So the issue is being able to authenticate all of the packets that you receive in a possibly lossy stream. There we go. So in, say, video delivery, for instance, which is kind of the target application for this, the data that's received has some properties that are important. First is that the payloads have a deadline. If you don't receive a particular payload by a certain point, then you might as well just throw it away. You may as well not have gotten it at all. So in some sense, retransmits are not interesting. The other big problem is that with multicast video delivery, there are many receivers. So one of the things that TLS relies on for efficiency in its encryption is that it only uses asymmetric crypto to negotiate a symmetric key. And the symmetric key is then known only to the sender and the receiver, or it's known to each peer. So if you didn't originate a message encrypted and signed with that symmetric key, you know that the other party did, and notwithstanding key exfiltration attacks and whatnot. The other problems with video that are, or with unreliable delivery are that datagrams are lossy, and that retransmits are not appropriate, because in multicast you're not. I mean, how would you retransmit a multicast packet? Right? You'd have to have it transmitted to you via unicast. You need some signaling mechanism, and you don't even know who the sender is most of the time. So the naive solution to this is to sign individual packets, right? So you divide your video into individual packets. You leave enough room for a signature. You sign it using an asymmetric signature algorithm, and you append that to the packet. So the pros for this approach, being the naive approach, is that you can verify every packet that you receive. The big con here is that it's very CPU intensive for receivers. It may also be CPU intensive for the sender, but that's not the case that I'm targeting, because typically the sending infrastructure is also involved in video encoding, which is much more CPU intensive. But the client may have dedicated hardware for video decoding. It probably doesn't have dedicated hardware for doing signature validation. So
Tesla tries to solve this problem not by using asymmetric crypto, but it introduces asymmetry by holding back the key, the symmetric key that is used to sign the packets, and releasing it after it expects all the receivers have received the packets that were signed with that key. Right. So essentially, as you can see in the diagram here, there are 3 packets that were signed with key K1. There's a deadline at which all receivers must have received that key, and then it releases key K1, and the receivers can use it to verify the packets. Then it has to use a different key for any subsequent packets. This is a good scheme in certain circumstances, but it does have some cons. The big one is that it requires weak clock synchronization, and while this works well in controlled environments, in adversarial environments, you run into problems where where attackers can delay packets used for clock synchronization, and therefore cause targeted receivers to process packets that they wouldn't otherwise have processed. The other big problem that we have is that if you try to use this interdomain by using, say, NTP, well, even with NTS, which hasn't even been standardized yet, I don't know that I, as an enterprise, or I as a CDN employee would want to trust NTP as a security mechanism for the streams that I'm publishing. So once the key's been released, all bets are off, and any receiver can then inject a packet signed with K1 to any other receiver that is still willing to accept them.
Sorry, if we have enough time, and I still didn't get the trick of this security thing. I mean, for an invalid receiver who's not meant to be able to decrypt this, how does the scheme protect against that if the key is transmitted?
So this isn't an encryption scheme. This is an authentication scheme. The idea is that the publisher, I mean, and this is not the algorithm that I'm talking about in the rest of my talk, right? But the idea here is that in order to keep one of the receivers, which in order to authenticate the signature has to know K1, from injecting packets into the stream, it cannot get K1 until after all the packets have been received. Yeah, sorry, I should have made that clear. Okay, no problem.
Yeah, Stig here. If you have time, I have a pretty naive question, I guess. I'm kind of wondering, do you really need to rely on NTP? Couldn't you say that this key is valid for whatever you received within the previous few hundred milliseconds or something? I mean, do you need to use like kind of...
Well, the problem is that an attacker that is trying to target you can delay the packets in a way that causes you to authenticate something that you wouldn't have authenticated if it were expected network delay. I don't want to get too far into analyzing this, though, since this is I'm sort of where I'm going with this is that there are situations in which you really do want asymmetric crypto to provide your asymmetry. So one approach that I tried, and we actually went to SecDispatch with this a year ago, was a signed manifest. So essentially you send a bunch of payloads, and then every so often you have a manifest that is signed, and this manifest contains hashes of all the payloads that you sent previously. So the pros of this is that it's lots of fast hashes, only one signature per n packets. But the cons are, well, what if you lose the manifest? Well, you can send it multiple times, but you're still going to lose some of them. And when you lose a manifest completely, all of the packets that it signed are now unauthenticatable, and so you may have some huge gap in your video. The other problem is kind of a conceptual problem, which is that the fate of the authentication information is separate from the fate of the data payloads. So you can receive all the data payloads and not receive the authentication payload, and that would be a perfectly normal situation to expect on the internet. And in that case, all of the data you received is now useless because you can't verify it. So a different approach is to use chained integrity, right? So here you have a series of packets where each packet contains the hash of the previous packet, and then occasionally you have a signature that allows you that acts as the trust anchor for that sequence of packets. So the pros of this are, again, sparse signatures. You only have a signature every so often. And there's tolerance for signature loss, because if you lose this signature, you just have to wait for the next one as long as you receive all the packets in the meantime that form a chain back to whichever one you haven't been able to authenticate. The problem with that is that one loss breaks the chain, so it's not tolerant to loss in a way that is interesting. But it is better in some sense, because the authentication information does share fate in a limited way with the data that's being transmitted. So a slight refinement to this is to have redundant integrity. Right, so here you have two hashes. So essentially every packet contains the hashes of the two prior packets. So this gives you essentially two ways of getting to any packet. So you have two chances to get a packet hash. You'd have to lose two in a row in order to break the chain. But that's still not good enough, because you really just, instead of having a loss rate of p, you now have a loss rate of p squared, which is still fairly high, presumably, in when you really want to be loss tolerant. And this can be a lot more often if loss is bursty, which it often is, where you will lose multiple packets in a row. So really what you want is redundant integrity that is patterned in such a way that it is resistant to expected patterns of loss. And this is what we implemented. So during Sec Dispatch last year, Ecker just like out of the blue remembered some paper from 17 years prior that described a solution to the exact problem we were having. And this is the Gole and Motodugu paper. This provides a DAG of hashes with periodic signatures. So in this diagram, the arrows are directed in such a way that a hash of a packet is contained within the packet at the end of the directed arc, right? So in this case, for instance, the hash of B0 would be contained within the packet A4. Right, I'm not going to go through this. Believe it or not, it's a DAG. This is actually a simplified version of what the algorithm is actually doing, but it's a little bit complicated to read the paper to understand how to do the construction. But it's actually fairly easy to implement the construction, because they almost provide an algorithm in the paper itself. So the pros here are that you always get two chances to get each packet hash, but they're better distributed in such a way that even if you lose both packets that contain a hash of one of the packets in the stream, you are very unlikely to lose many other packets as well, because there's additional redundancy. There are many ways to get from a signature to any particular packet. And I've proved this with some running code. The cons are it's complicated, as I said, and there's also a variable number of hashes per packet, which means that the data that you're transmitting, you must be able to segment it into variable length pieces, which might be a problem for some payloads, but not for the use case that Jake and I are working on. So the key properties of this are that it has optimal resistance to bursty packet loss. There's a nice proof of this in the paper. And as I said, it has tolerance for signature loss, just like the other chained algorithms, because you can just wait for the next signature to come through. One of the other nice features there that follows on from that is that if your receiver is smart, it doesn't have to authenticate every signature. You can send more signatures than you expect the receiver to actually authenticate, and it can just skip some of them as long as it knows it's going to get one eventually within its deadline. So the next steps are running code. I have code that is running now. It's not public yet. I hope to make it public in the next week or two. Just have to go through the legal department at Akamai. And then there's a bunch of design choices that need to be made. I put one issue in the GitHub repo that would be interesting to get some feedback on about opacity versus overhead. So the way that I currently have it implemented, it is not parsable without access to out-of-band metadata that tells you how long specific fields are. I don't know whether people feel strongly about making it parsable even without that metadata. And then just in general, we need to flesh out the draft. But I'm curious if people have questions or if they're interested in doing this work.
Totally separate again. So how or why is something like GMAC infeasible?
Something like what?
GMAC, GCM, Gallo counter mode for, the built-in authentication that comes along with it.
I'm not understanding the relevance.
If I understand it correctly, the whole point was to authenticate, right? So now if the authentication comes for free with the crypto, we can look at the overall complexity of the system. GCM seems to be, something that is said is working extremely fast in, crypto hardware. So basically that if I haven't tried to analyze what it means if you have lossy channel, but otherwise the question really is, why don't we just use crypto with GCM, because that's self-authentication?
Yeah, sorry, I'm not sure how that's relevant to loss, right? So the issue with authenticating a lossy stream is that if you can't authenticate individual segments of data that you receive, and you need to have the whole, like all of the data in order to authenticate it.
I think you gave me the right answer faster. Well,
I looked on Wikipedia. It says GCM is symmetric.
Right.
Yeah. Okay. That too. Okay. Any other questions? Anyone interested in using this or helping out with this?
Steve again.
Thanks, Jake. Jake's volunteered to help.
So I had one thought, the one thing I'm wondering about, maybe stupid question again, but you can do like a manifest, as you said, they'll say every 5 packets or whatever with signatures. So I was kind of wondering if you take that manifest of 5 packets, then you use some redundant coding of that, and you include, parts of that in each of the next 5 packets or something like that.
So that's very similar to what Jake is proposing. So we were not actually the way that we are intending to use this is not to actually put the video into this payload, but actually to use this stream to distribute a manifest, a rolling window manifest of hashes of video packets.
Okay.
So
just one more clarification. This, by the way, reintroduces the problem Kyle mentioned about fate sharing. So I'm arguing we should live with that, but.
Well, it being a rolling window means that you'd have to lose an awful lot in a row, in which case you are probably going to run into, a skip in your video anyway.
That said, my intent is to run the manifests as part of the same multicast group on a different port. So they have some amount of fate sharing in the routing layer, but that's different.
So I didn't really ask the stupid questions intentionally, but
No.
let me take them as a proof that this.
So you should take my response as I'm confused, right?
But let me take these Eckert guys. I'm the one with the T, the stupid guy. The other one without the T's.
He's got.
So as a proof that this obviously is the best working group to be the specialist for new crypto or authentication mechanisms, right? So I think the best role that this working group would have is basically with anything it produces, supports the notion of, the requirement to do something like this, because I would say the fundamental reason why, a fast mechanism for asymmetric transmission like that exists a lot more in multicasting than unicasting. Mm-hmm. Right? Because in the unicasting way, kind of all these symmetric things have a lot of good solutions, whereas the asymmetric stuff is, effectively reduced. And then basically here, your whole argument would be in multicast, we can't do it in the same way. Mm-hmm. We need the asymmetric stuff. So if basically this working group is required to produce something that says you really must do this, and then some other working group that really knows what crypto means, would basically standardize whatever is needed in this case, right? But I mean, this is not a protocol working group, right? So and PIM wouldn't be a protocol working group either, right? This would have to go whoever does authentication, encryption, or authentication encapsulation, right? I don't even know what it is this time, but I think we could only create the requirement saying this is a cool thing and we really want to have something like this.
Yeah, I think you're probably right. I skipped part of the spiel that I had prepared, and I probably should have included that, which was, does it make sense for Mboned to take on this work? The reason I brought it here was that this is the group of subject matter experts about the application that we're planning to use it for. But do we need to reopen MSEC? Should I go back to Sec Dispatch? What are the next steps for this?
Jake Holland, we took this to Sec Dispatch last time, and this is where we got the feedback. We're happy to do it again and to open a working group for it. Their feedback was that we need to get support. So that's part of what we're doing here, is this being the application experts that can talk about the need for it. I don't know if it has to be like an informational draft declaring a need for it, or if you can just show up to MSEC and raise your hand, show up to Sec Dispatch and raise your hand at the right time. But one of those things might be useful. Yeah.
So I don't know the security area well enough to say how they want to run their stuff, right? In terms of, to me, this looks like whatever ESP or whatever other stuff is define a new, form of crypto profile for that would effectively do this stuff. I'm not sure about the additional complexity with the metadata or something, but I think it's very viable for them to say we need to see some interest. So the question is, what's the best type of interest we can express, right? So this is.
I would look to the chairs for guidance on this.
So I would turn to the ADs for direction, but what I've seen quite a bit in a lot of work, we cross boundaries all the time. The interest is coming here. How do we show interest? Do we adopt it? That'll wake them up. I don't know. We finally push through the ISGQ, and then
so much more feedback on a document with crazy
Yes.
new crypto stuff than for all these other documents you're doing here.
yeah, and advance it to the queue, and you'll get feedback.
Wow, you're tall. To me, it does feel like having this discussion in a group that has a lot more crypto people would be much more valuable. Like, it seems as though there's enough stuff here that's easy to shoot ourselves in the foot with.
This is Greg. I don't disagree with you, but I think I would frame it differently. I wouldn't say more valuable. I would say additional value.
Okay.
The use case is just as important. They don't see a reason to do it. We do. So together,
Yeah.
right? So requirements are clear. There's a solution here that may be enough. Even getting their sanity check on something is usually the case. When we cross boundaries, it's not often to throw it over the wall and have them do the work. It's just to ensure that those experts get a chance to review our work.
Yeah.
I didn't say in every case, but that's often the case.
Yeah. So not just review our work, but hopefully be involved in making sure as it progresses that it.
Yeah, well, part of the review is say, no, this is a lame idea. We got a much better way of doing this. Did you understand the recs? And we go through the process, but there's a process.
So one thing I would say is that as I've presented it here, there's nothing novel crypto-wise there, although there are some things that we would like to do that probably would probably raise the hairs on the back of Ben's head if we actually implemented them, such as like truncating hashes, right? How much can we do that and still have a security margin, right? So that's the kind of thing where we would definitely need security area input.
Well, but don't you feel that the amount of crypto review on, there's this metadata channel, which I don't know, right? So there were these parameters that you said, right? So I don't know anybody here who could, and that may impact whether you need a metadata channel or whether we feel, we can just statically define a profile that will be fine forever. And then somebody comes around and says crypto agility. And so, there's a lot more stuff, which, I think if we do it with review afterwards toward the end, right, we do everything, working group last call, and then core issues come up, right? So I think it's fine to get started with this one block requirement use cases, one block proposed solution. Worst case, this is getting snipped in the middle, and the solution goes to a working group that does it better, right?
Thanks. Anyone else? All right, thank you.
All right, Jake, come on down.
Hi, Jake Holland, and I was going to talk about the hackathon.
This will work.
Yeah. All right. So my focus at this with this effort is about getting receivers deployed that can actually do the ingest. So the idea is broad deployment for something that's going to implement the discovery, because the new discovery that we've recently passed last call complicates the multicast application, and making sure that it's going to be viable to get it in, and the crypto that we believe is going to be necessary for the receivers also is going to complicate the application. So I'm trying to merge this into a library and get this and provide a proof of concept that it can be integrated, and in fact go ahead and do some integration on some widely deployable clients. To that end, I published a libmcrx library, BSD licensed. I have it running with basic SSM receive, and it's compiling on Mac and Linux, and in fact receiving data. My intent is to add the AMT gateway with Dryad discovery with the local DNS-SD discovery, so that it's critical to the use case of deploying multicast that we get that when you can discover a local relay, you use it so that a locally capable multicast network actually provides multicast. If you just connect to a remote relay, you will sort of ossify multicast before you can get the actual replication. It has to go over the access network. That's my view of it. The place you get the most gains is in those fiber networks and in the cable networks where there's physical bits on the wire that don't have to get transmitted because you did it in multicast. So that's what I'm trying to accomplish with this. And the other piece is the authentication, which on the internet we have to send over untrusted networks, and in actual deployment it's going to be critical to get that working. That's why we've started this work. We're going to try and make it run, and it's going to go into that library with the same API or a small extensions to the API that's there now for how to do the receive. From the application side, it will be relatively invisible. So at the hackathon over the weekend, I got it running and integrated in the upstream for the TAPS reference implementation. It's a Python implementation of TAPS. TAPS is working on a sort of replacement API for socket libraries. So I've been participating with that group, and I have now integrated this multicast receive library into that reference implementation. It was running. It is research code, so this is not super deployable on its own, but it was heartening to see it, be successful with the API that was there. And I think it does represent a worthwhile proof of concept. The other thing is the upcoming idea, which is I have a prototype running, which uses the same API and runs under Chromium, providing a JavaScript API, which you issue a join, and now you start receiving UDP payloads. Once we've integrated the discovery and the authentication, this is going to mean that you're going to receive authenticated payloads, and you'll be doing it whether or not you have multicast capability. But if the local network does provide multicast capabilities, then you would be getting it with multicast. So that's the basic idea. This also is running, and this is going to need a lot of work. In fact, yes, this is my to-do list. This is not going to be, done in November. I doubt it will be done in April. But I don't know, depending if I can get any support. I can type all of this. I think I know what to type. I think I know how to make this go. But there's a lot of pieces to put together, and before it can really be deployed, I think all of this, or appropriate substitutes that simplify, are going to have to be there. So yeah, if you know any grad students that want some good experience, or that you know, then I would love to hook them up. If people are interested in this, I would love to get some assistance on working this out. And I'm going to start typing myself, and I would love for people to come join me.
For friendly mentoring, talk to grumpy old troll.
Indeed.
What's their carrot?
It's a wonderful experience. You know what? I'd have to talk to him. It depends on, I don't know. Stig.
Yeah, hi. Just a thought, or maybe you've done this already. Is it possible to, use shared libraries, so like preloading, so that you can have like a pre-compiled existing application using the socket API, and then be calling your AMT library?
That is an interesting idea. So the socket API is arguably a poor choice for some of this. You need to, I'm using a socket API underneath it, of course. It's not really cross-platform. It doesn't work cross-platform. There's different sock ops you have to do to actually issue the join. There's, you get a, if you want to write that, that would be awesome. I don't know how to write that one, actually.
I know on Linux, someone wrote some open source code like a decade ago that did something like this for SSM. So the application just joins StarG as usual, but then you have this library between the app and the kernel that could basically do an SCOMD join for some other group.
Right. So that's kind of what the role that this library is trying to fill. You do have a relatively simple SSM join API, and you're, the hope is that the receive side use cases for applications actually can work with this app, with this API, and that's going to be somewhat simpler than trying to use sockets. That has been my experience with messing with it so far. I think it, as with all code, it will presumably get refined along the way, but yeah.
Yeah, at least I have a feeling that it could be possible to do something like that, but it would be, operating.
I don't know. Sockets are, so like, one of the lessons from TAPS is that the working group was formed because like 3 different groups tried to do this, not for the more complicated case of multicast with like extra features, but just for regular, ease of use on sockets, and ended up deciding actually this is kind of complicated, and now they've been hammering at it for a couple of years, and maybe they'll have a good API before long.
Yeah, at least if you're interested, I could maybe point you to.
Oh yeah. Please do send.
I think it's 15 years old code.
Great, thank you. All right, thanks.
Saints work. Saints work.
Thank you for maintaining a good multicast presence at all the hackathons. And yes, you're doing the work of the Lord. Okay, we are. Leslie, come on down. And Glenn. So, the media ops BOF, there was a media ops BOF occurred Monday. Who here in this room attended? Okay, so about a third of the room. And this was the first BOF after the one in Chicago. Was that correct? There, I remember Chicago.
It's the first formal BOF.
Okay.
That was a bar off.
That was the bar BOF in Chicago. I remember that. And there hasn't been anything formal, but you've had the list going. And
Right. So we've been talking about video at the IETF, had an informal group over the course of the last 2 years.
Yeah, so since Chicago was kind of overwhelming with the number of people in the room, we went to a much smaller group, sort of less formal, called the Video Interest Group, that's been meeting at every IETF since then. Which has been pretty good because it's allowed the nascent ideas to sort of form and say, well, what would you work on? How would you tackle things? And I think we've developed a really good community of interested parties, both individuals and organizations that would support the topic space. But now it's time to maybe make it a little more formal and do a little bit more. That's why we called for the media ops BOF to sort of open it up to the rest of the world.
So people who were in the BOF have heard this part of the song and dance before. So part of what we were hoping to do with that was to highlight the fact that there are many video activities that are ongoing at the IETF that don't actually fit in any one particular place, and identify gaps in IETF work and areas of incompatibility with video technology development efforts being carried out elsewhere. So for example, Glenn gave a presentation about the SMPTE dependencies on IETF standards. There was representation from folks involved in the SVA, the Streaming Video Alliance, in the room. And these are all other organizations that use IETF standards in ways that might be surprising to us.
Yeah, so on that, for people that live in the world of the IETF, they're probably not very aware of what's going on in some of the other orgs. SMPTE is a Society of Motion Picture and Television Engineers. Basically, they do TV and they do broadcasts. They do production. They run studios. They do all that kind of fun stuff. That whole industry, kind of like the telephony guys, migrated. And we had SIP. They're migrating from a protocol called SDI, which is a point-to-point protocol that all the gear is wired with, allows them to stream their streaming, move content from sources to destinations in studios and in production environments. And then ultimately to a broadcast tower or a cable network. They're migrating to this thing called IP. And they're just discovering IP networks. And so one of the first things they did was create this suite of standards called 2110 in their parlance, which essentially is, how do you do all this kind of stuff we've regularly been doing over SDI? How do you do over IP networks? They learned a lot about updating their stuff to make it work in that environment. They also learned a lot about IP networks, things that worked for them and things that didn't work for them. And so they, one of the things we presented was this long list of normative references that they have back to us in the IETF. And unfortunately, the director of standards, Thomas Bauza Mesa, was supposed to be at the BOF, but he had to go to LA for a meeting at the last minute, or he would have been able to give you a really good in-depth overview on it. But the takeaway there is that there's these groups that are now, just like telephony guys did, they're starting to become dependent upon IP networks. And so part of the takeaway for me on this is that there is this new set of parties that are really dependent upon us, and they're really interested in the stuff we do here. There's an opportunity here to fire up some work in the IETF and bring these guys in as well, because they have stuff that they want to talk to us about. And it'd be possibly use some work, successful new work for the IETF, but also a way for all of us to make our TV shows and movies that we all love a little bit better.
And I think Torles has something he wants to talk to us about.
Yeah, so I mean, the example, so even a couple of years back, I've seen really crazy ways on how some of the broadcast equipment has been, app using IGMP, even in the way they documented in their stuff. And, we do have existing working groups where they could have come to, like this one or PIM or others, if they have any questions about the technologies that they're using. So I'm just wondering, what's the process by really, because we have adoption of IP technologies and all these different technologies for such a long time, and there have been always the ongoing pain that everybody who adopts it thinks they understand this stuff better than we do.
So I think part of the problem is that for the people who are working in those groups, even if they ever looked at an IETF schedule or at the IETF webpage, heaven forfend, would have no idea where to plug in, right? I mean, maybe they would understand, well, I'm using V6 technology and I'm going to do it this way. I'll find, oh, look, here's a V6 working group. And it's like, none of the work items are relevant to what they're doing. So the point...
Can I interrupt? I don't believe this, right? Because, I mean, I've been mentoring people as well who came in there. Somebody asked what the technologies are, and then they've been asking around with the mentors who knows these technologies.
I didn't say nobody succeeded.
Agree to disagree.
Yeah.
And university work, man. These are people trying to get the job done. They get really paid to do it. They don't care. They find a solution and they go after it. They can't get a spec read and clarified in time. They do it the way they want to do it.
No, I think we agree on that. What I'm saying is I disagree on the fact that somebody, if they wanted to come to the IETF, wouldn't be able to figure out where to go to because we're helping them with that.
So one of the problems is that you actually stand up in a working group and you say, here's this problem, and you get told that there isn't a problem. Sort of like now.
Well, and specifically to this point, as me as an ITFer, when I go and work with my colleagues in these other groups, which I'm a member of SMPTE, and I'm on the board of the Streaming Video Alliance, I will tell you I've received vocal feedback many a time from people who have tried to come in and engage with us. We do have a bit of a reputation of not being the friendliest crowd to open the door and welcome people in. Part of the idea that behind this is it could provide a safe video, a group that understands video concerns, also understands the IETF, and could help bridge them into it. So how that might work in practice, for instance, would be, hey, I've got a problem that's video related that I think touches IP networks, okay? First step. Step number 2, I would like to find a bunch of like people at the IETF who understand this problem space and who would work with me to create sort of an essence of IDs that could eventually either create work in this space or could get taken over into another working group that's working on the specific stuff such as Mboned. Once those ideas are allowed to be developed and refined so that they're ready to be brought into a group like Mboned or some other group within the IETF. By the way, time, it turns out to be, is a huge new topic for a lot of these video guys. Who knew, right? But they has faced that exact problem. How do you make those ideas coit before you bring them forward and into those working groups?
And I didn't mean to imply that nobody succeeds in bringing their stuff in. I think that you're identifying that you have successfully helped bring some people in and sort of smooth their access to getting the right answers. And we're saying there are some people who don't succeed. Maybe they haven't found you, but I mean, the point is there are people for whom this doesn't work. And I think the gentleman behind you would like to make a remark.
Hi, Femi Kamalafi, Arista Networks. I agree. I think this is very much needed. I know from talking to customers in the kind of media world that even a concept like an IP address is quite kind of scary to them. And they always want to try to avoid a lot of the kind of technical details. So I think what you're suggesting makes a lot of sense and very useful.
Great. So in terms of trying to do this type of work, some of the challenges we outlined were the fact that this video work is multifaceted, covers a lot of traditional areas, no clear single home for it. And therefore, some coordination would be useful, as Glenn was just outlining. And so we kind of wound up in the ops space for the BOF, in part because there's not specific proposals for developing specific technologies at this point, but rather more a set of operational issues that people are encountering and finding solutions or creating creative solutions to address them. So in terms of the BOF, we had about 100 people in the room, 100 and something people in the room. Yeah, there are a lot of people there, and there's general support that there is work here that is IETF appropriate. A reasonable number of people who are willing to sign up to the mailing list. Here's a plug. The mailing list is the mops.ietf.org mailing list. We've just set it up because we've been camping out on a different mailing list until now. So please do sign up if you're interested, and don't be surprised if there isn't yet a lot of traffic. But also an outcome is that clearly we were not clear in scoping the problem space, partly because this is not a traditional ops group for a particular protocol. So we heard that, we're willing to work with that, and we will be back with some creative solutions at some point.
So just from the process, are you trying to be working group forming, or what's kind of the process steps that you're trying to achieve next?
Yes, this BOF was a working group forming BOF. That's the intent, to ultimately form a working group.
So were there specific work items proposed for the working group?
So Jake actually has proposed that we consider doing a taxonomy of issues in this space to help map out the space, for instance. I think that's part of what we actually have to do in terms of clarifying what the scope would be.
Yeah, because I mean, the way you explained it is the typical thing for quote working group is kind of maybe not really. It's more like a consultation group would be, another bigger scope of what this starts out be, right?
Yeah. So what we really wanted was to do something like an interest group, which is why we were informally calling it a video interest group when we were meeting informally. But the problem with trying to meet informally is you don't have bounds on your discussion, right? So no charter boundaries. And also, no possibility of actually answering the question because he's gone off to take a call. Shall we move on? Okay.
I did want to make one point. In the video interest group that we ran for 2 years, and the notes from it are online, the presentations that were done are online. There were repeatedly, we ran basically like a little mini work group. So people did come and give presentations and actually have things, hey, I'm working on stuff here that's relevant to the IETF, and this is work I'd like to do. And we kept having to say, well, that's awesome, but we're not an actual working group. But it's awesome you've got work you want to do. So there's a pipeline.
Warren Kumari. So yeah, I mean, this doesn't look like a normal working group, but I don't think that's necessarily a problem, right? It's fairly clear that there are a lot of people who want to do some sort of stuff. It doesn't fall into the regular working group type design, but that doesn't mean that it's not worth doing. I think that might just be a signal that we need something else other than working groups. I think for now, we're going to try and leverage it into a working group because redesigning stuff and something else is a really big job. I think there is some sort of precedent for this, which is things like sec dispatch. Right? Sec dispatch doesn't always do its own work. It looks at things and sends them off other places, and that kind of seems like a model that we can abuse into this. But you did come back.
No, I think that sounds great, and I wasn't meaning to with the initial stuff to reject this. I was just hoping that nobody would have said that Mboned or PIM have been, nasty to people coming in from the outside.
No.
Right, so because I'm hoping we're not part of the problem, but really part of the solution. From that perspective, if we find a way to, not force this thing to unnecessarily do some stupid, draft work that's really just there to, but you sound very, sounds
Right. And so that actually brings us to why we're here, because we were invited to come and tell you all about this work. And indeed, given this sort of dispatch-like structure or intention of the work, we could certainly see while the MOPS working group might attract people to come in and talk about video challenges, we could certainly vector participants to come and take actual multicast issues here for discussion amongst people who actually will be able to point them more precisely at solutions. So we're trying to be part of the, helpful to other working groups. It's not about stealing anybody else's lunch.
Yeah, because it turns out that, video and multicast kind of have things in common. Who knew?
Yeah, so that's actually, an observation I would have. It seems at times that the video folks have taken great pains to avoid using multicast when they clearly, and they will state, we have this problem with, it's a lot of data. It's a whole lot of stuff. We got to send it everywhere. And it's like, well, no,
right.
We do have a solution here. Yeah. So yeah, we would love to, play a role because we've been trying to solve a lot of these problems, and we'd like to know, we would love to have better feedback from the relevant groups that would consume it. That is this helpful? Is this not? Is this something they're aware of? We're working somewhat assiduously trying to come up with solutions and tools to solve these problems. So.
Right. So, this is what I threw up on the slide in preparation for this discussion. I'm happy to take suggestions for other bullet points. And one that pops to mind just now as you're describing that is, we might want to make sure to have sort of a standing item depending on the scheduling of, hey, the other working group is meeting later this week. Here's some topics that should be covered, or hey, we met earlier this week and this is what we went over that's relevant to this working group. I don't see why we couldn't do some purposeful cross-pollination on the agenda, for instance.
And don't schedule them at the same time.
Okay. Yeah, that would be good.
We're updating our conflict list, and we will definitely add you guys in there.
I just like to add from a co-chair that I see this as completely complementary.
Great. Thanks.
Yeah.
Thank you.
Was that our last slide?
I think so.
Awesome.
Right. Yes. So thank you for sharing, and we look forward to collaborating and. Cool. So first, blue sheets. Has everybody signed the blue sheet There's only one. It's blue sheet. We have a second one, but I don't think we need it. I think we can fit everybody on it.
Trying to save blue trees.
Yeah. And Greg, did you want to, we have a little bit of time left over. Did you want to give a little bit of an update on beer, how things are going, and more specifically, what we in Mboned should be caring about with regard to beer?
So I guess what I should have done was like have a slide with the RFCs and status and where we're moving. But I think what I throw out is I see.
Probably less interested in that, more just.
Well, sure. I mean, that's a chair update of the group itself. But what I'd say, looking around the room of people who I don't see in the beer room, I think it's time to start paying attention from an ops level. There's a lot of POCs taking place out there. There's a lot of discussions, some quick early deployments. And I think we're going to see a lot of discussion around transition mechanisms. What's the word I'm looking for? Is the type of draft that's a best practices, use cases, things that are starting to come out quite a bit. So if nothing more, pay attention. Maybe pay attention to the beer list itself. Use cases would be interesting to take a look at and see if it's well representative of what you're working on. If nothing better. But ops inputs are always valued at the protocol side. We can't just be doing this stuff in a vacuum. So pay attention, subscribe to the list, and come have fun.
Okay, with that, does anybody else have it? Oh, Turles, come on down.
Wait a minute, sir, what's your name? It's like he's motivated by a need to just stir.
I was just wondering if the context was really from Mboned or from PIM earlier. But so the trace route stuff is also a question of the API. So I was talking with Dan Wing, and so in the ICMP reply, the question is always depending on how many information you get back. You always get the port number back. If you don't have an API where you get more back from the payload, it's the safest way to get the port number back, different for every packet. Otherwise, you'd have to have a nonce in the payload, and then the API needs to have sent more. So.
Cool. All right, with that, I guess we are done, but you can't leave. So everybody, the meeting is not over until 5:50. So everybody, hands folded, feet flat on the floors, eyes forward, and please sit in silence for the next 40 minutes. But thanks for coming. We'll see you in IETF 106. Okay.
We are working on this.
Anyone else? Last chance?
Well, no, actually, the tree's already been killed. We wasted that. We wasted its precious life.
I always felt like it has to last longer than the life of a tree.
Built furniture. Actually, as Thomas pointed out, trees used for building for paper are planted solely for paper.
So not in all cases, depends on the species. In fact, early on, the West Coast was, of course, the old